Hello, my name is Zhenyu Lian. Today I'm going to give you a presentation about world well-known stadium, Beijing National Stadium. Beijing National Stadium was the main stadium for Summer Olympic Games in Beijing 2008. Now it is under renovation and will be used for 2022 Winter Olympic Games. It was designed by a Chinese and Swedish architect and engineering team, and is a multi-using sports stadium. During the Olympic Games, soccer, trekking, and field sports were played here. And besides, it also hosts concert and entertaining events now. Beijing National Stadium is 68 meters high and 332 meters long. The construction required more than 17,000 workers and cost about 428 million US dollars, and consume a total number of 121,000 tons of steel. The total construction time lasts 4 years and 6 months. The maximum capacity of the stadium is 91,000 people. As for the design concept, the idea came from the shape of an old Chinese ceramic vase with a million of strings wrapped around it. It shows the meaning of inclusive and hospitality of Chinese people. We welcome everyone came to Beijing and will provide the best experience. Besides, the stadium followed the concept of green construction and energy conservation. ETFE membrane on the roof can control the heat get in the stadium and prevent rainfall and provide extra protection for steel. There's no membrane on the side to make sure wind can get into the stadium. There are many design constraints of this stadium. Firstly, it must have ability to resist magnitude 8 earthquake. Beijing located on earthquake zone. There was a strong earthquake with magnitude 7.8 happened in Tangshan City in 1976. This city is only 180 kilometers from Beijing. Since the stadium is so big and the vibration frequency is continuously changing for different parts of the building. In order to meet the code of seismic design of building in China, the engineer and the design team divide the whole structure into structurally independent segments with 200 millimeter wide movement joints between them. In this case, even one part of the stadium collapse, it won't affect the rest. In Canada, for this kind of design, we need to follow the seismic hazard information in the National Building Code of Canada. During the construction of stadium tiers, the roof of Charles de Gaulle Airport collapsed and killed 4 people. Since Bernas has similar roof design, the design team had to remove the retractable roof. The opening on the roof was bigger now and used less steel so that the structure was safer. For construction of big stadium like this, we need to follow the design code of sports building of China. The roof structures consist 3 different steel trusses to support their load. Firstly, there are 24 main portal girders regularly arranged around the concrete ball to support the steel structure, each comprising 2 inclined truss elements and 1 vertical diamond-shaped element. The truss member arrangement of the column head for lower portion is 3 column truss elements put close together so that they perform like a single large steel element. And for the secondary truss of the structure is used to connect the portal girder to roof trusses. The evaluation of static loads consists of dead, light, snow, wind, and earthquake load. The results are shown here. Both 3D model evaluation and prototype testing were performed. Left one is the overall load distribution, and right one is the condition of single truss support member. In order to test the curved truss member, finite element analysis was used and assumed that the member is under elastic stage. The most critical area is the starting point of inner part of bending area, and in order to protect the critical section, The member was thickened to increase its stiffness. As for the connection problem, all materials used are steel. The way to connect them is a major problem since most of them has irregular shape, and this makes the connection even harder. In this case, welding was chosen as best solution. In order to better fit the curved structure, HSS section was chosen to twist over the curved intersection of the wall and roof to maintain its outer edge parallel to the section. HSS section has a strong in torsion, which is essential load to the member to members will experience at round intersection of the roof. In order to create a smooth and continuous connection between each segment, welding joints were used. Well, there are two major challenges for welding joints. Firstly, it has to be performed with temperature between 15 to 23 degrees Celsius. And the total length is more than 600 meters with 128 welding joints need to be finished. Luckily, there are enormous number of skilled workers who are willing to make contribution to their country's development. They work in the night to ensure the temperature, the number of workers, and their skill made amount of welding joints less difficult to finish. According to the Chinese Seismic Design Code of Building, national stadium has need to meet the second standard, which is repairable damage when subject to an intermediate earthquake. An intermediate earthquake usually has a 500-year return period. Design team used the performance-based seismic design, and the target assigned to primary truss member shall remain elastic or near elastic, and the secondary truss member are allowed to sustain severe damage. It is the most cost-effective solution and save large quantity of steel. In order to meet the weight to thickness ratio, the results of plate thickness calculate between 7 mm and to 100 mm, and most of the plates are less than 70 mm. And finally, the design team decided to use a 1.2 meter by 1.2 meter box section with thickness of 70 mm for most section. As we can see in this diagram, most of the truss meets the requirements of achieve elastic behavior and only a few sustain damage. The design was also approved by experts and meets the principle of conservation. Here is some calculation of how to determine the shear and moment of each support on the truss member. And there are some sample results from the calculation. Both this section came from research. As for the fire safety of stadium, according to Green Guide from UK, the evacuation time should be less than 8 minutes, considering people may gather on the concourse area during the evacuation. There are 6 concourse areas in the stadium to ensure amount of space. And the gangways in staircase was designed with 1.2 meters width to prevent multi-line of evacuation cause crashing and death. For the internal fire resistance, the design comply with code for fire protection design of building in China. Then they apply the concept of carbon by using sparklers, smoke barrier, and the dynamic smoke control system in the stadium. Lastly, additional fire protection was installed for the critical structure steel roof member within 6 meters of spectators. Lastly, let's take one more look of this spectacular landmark in Beijing. Show our highest respect to the designer, engineers, and the constructors who brought this structure to us. Thank you very much. That's all for this presentation.